In that group, we are going to have three kinds. One is data definition language, and also we have a data manipulation language, and also we have a transaction control language. So division will going to returns the quotient value, and modulus will going to gives you the remainder value. The all operator is used to compare a value to all the values in another value set. Everybody, a warm welcome to one and all. I am Rohini TS, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. So in our today's session, we are in the session 1 of the chapter 14, that is SQL commands. So in our today's session, we will be discussing about the introduction part of this chapter, that is what do you mean by SQL commands, what is the need of having this SQL command, and also we will be learning regarding the SQL architecture. Then we will be learning about the SQL commands. So that includes DML and DDL, that is data manipulation language, and also we will be learning regarding the data types in SQL. So till now we have learned the data types of C++, data types in the DBMS, and also in our today's session we will be learning about this data types in SQL, and also we will be learning regarding the operators in SQL, then SQL expression along with the SQL constraints. So that is what are the rules and regulations are we supposed to follow when we are having this SQL. So in the previous chapter of this session, that means we have discussed regarding the database management system. So that is what DBMS is just a collection. It is a software that will going to manipulate, that will going to allow us to access, manipulate, retrieve all the operations that we can perform on the database. Then who is going to give a commands to that database? Then who is going to question or who is going to give the query? That is with the help of this SQL. So that is structured query language, and also we are going to pronounce it as SQL, that is SQL. SQL is also structured query language. It is like a mother tongue for database management system. Not for database, it is a mother tongue for database management system. And also this language will going to help us in order to retrieve the content or in order to do some of the operations like selecting, creating, modifying the content of a database. So that is what the reason of having this SQL commands or SQL commands. So that you can see here, structured query language, in short it is a SQL. It is a non-procedural programming language that is used to create, manipulate and process the databases. So in short we will be calling that as a relation. We are dealing with the tables. It is a collection of tables or a group of tables it is. So this SQL or a structured query language will going to allow us in order to create, in order to do the manipulations, or if I wanted to change some content to the databases, we can do that, and also it will going to help us in order to process the databases. So that is the reason of having this SQL commands or structured query language, that is non-procedural programming language. And also this SQL helps to practice on SQL commands which gives an instant result. What is the use of having this SQL command? Mainly in order to generate an instant result. So whatever the commands that we are going giving at the time, this will going to be operate or it will going to act on the database, then it will going to give the result instantly. No need to wait for any number of minutes or hours. That is what we will be doing with this SQL. And it is based on the ANSI standards, that is American National Standard Institution. So they are going to give some of the set of rules and regulation. Based on that standard, this SQL commands are working. And also this SQL is a structured query language which is a database language for storing, manipulating and retrieving the data which is stored in the relational databases. Mainly we are dealing with RDBMS. Already we have discussed regarding this RDBMS. For example, if I want my database management system to be relational database management system, we have to follow some of the criteria. That criteria has to be followed or that needs to be obeyed. Then only I can consider my database management system as a relational database management system. That means whatever the tables we have, we are not going to consider that as a table. Instead of that, we will be treating that as a relation. So that that will going to have a collection of rows and columns. We will be calling that as a what? Collection of fields as well as collection of tuples or a record. That is regarding this RDBMS. Mainly this SQL or a structured query language is used to manipulate or in order to create or in order to view or retrieve the content which is already stored in the RDBMS. So now we'll see how this SQL architecture will going to work. So here you can see the diagrammatic representation of this SQL architecture. Mainly what is the use of having this SQL commands? You just imagine you don't know how to deal with a database management system. That means whatever you are going to speak that can't be understood by the database management system. Then I have to talk to database in a language that it can understand. For example, if I wanted to create a web pages, then I can't do it with English or any Hindi languages. What I am supposed to do, I have to use HTML, that is hypertext markup language. Then with the help of that programming language, that web page can understand what we are wanted to get it from that particular web pages or a website. In the same way, if I wanted to communicate with the database management system, then we must have some language. That language is called what? SQL, structured query language. So with the help of this SQL or SQL language, we are giving some commands. We are instructing the database management system in order to do some task which is favor of the user in order to get the result instantly. So you just imagine we are giving some commands to this database management system, but that can't understand. Then for that purpose, here we have a SQL query. That means I am asking some question. I wanted to get done my requirements. Then I am asking some question. For example, you consider I have a table called employee. So in that I wanted to search or I wanted to retrieve the records or a tuples which the person or an employee who is drawing salary more than 50,000. At that time, I have to put some query. I have to put some question. That is what? SQL query. We are asking the question. We are checking our needs. Then once it is reached to this query language processor, at that time, we are going to have this parser and optimizer. Parser is what? It will going to convert this SQL query into DBMS language, that is database management language, and this optimizer will going to do some modifications or optimization. For example, if you are not sending it in the standards, then it will going to make it some standardized manner. Then only it will going to be sent to the query language processor. Then that is what organized way of giving the query which is given by the user. So just imagine now SQL query, this will going to be given by the user or a programmer. Okay, but whatever the query that I am giving, that cannot be directly understood by this database management system. For that purpose, in order to convert this SQL query into DBMS understandable language, we will be having this parser. It will going to take care about the syntax and semantics of that query. Then this optimizer will going to do some optimization or modification as per the requirement of this DBMS. So together it will going to be feeded as an input for the query language processor. Then by taking the proper query from the user with the help of this parser and optimizer, that query will going to be reached out to the database management engine. And so in this database management engine, it will going to take care about the file. So it will going to have both the file manager and transaction manager. So here file manager, whatever the operation that we are doing with related to file, everything will going to be recorded and everything will going to be take care by this file manager. And if you are doing some transaction like whatever the operations that we are doing and whatever the events that we are making, everything will going to be take care by this transaction manager. For example, if I am creating any of the table or if I am deleting a table, those are all considered as what? Transaction. So what are the actions that we are performing? So everything will going to be take care by this transaction manager. So those content will going to be feed to this database management engine. So where I wanted to store my data actually, or to where I should reach in order to retrieve the resultant from the database management system, that is in the physical database. So we have our own content, or we have a raw content of a files and records or a relations or a tables in the physical database. So that will going to be, that query will going to be reached to this physical database. Then operations will going to take place. Again we are going to get the resultant from this physical database. I hope you all understood regarding this SQL architecture. So you can see here. So for example, when you're searching something in the Google Chrome, they are going to give you some options, like they are going to give you the choices. That means they are optimizing your request, they are minimizing the workload of the user. So same thing will going to happen with this SQL. So when we are executing any of the SQL commands in any of the RDBMS, at the time the system will going to determine the best way of reaching your request to the database management system, and also this will going to help us in order to carry out your request, and SQL engine figure out how to interpret the task. So that here you can see that we have a SQL engine that will going to figure out how to interpret the task. That means how reliable we can give the resultant back to the user or a programmer, one who is seeking the resultant from the database management system. And also here we have a various components which will going to be included for the processing. So that components include query, dispatcher, and also we have a optimization engine, classic query engine, and SQL query engine. So these are the components which will going to help us in order to optimize, or in order to process the, or in order to interpret the task which is given by the user to the database management system with the help of this SQL commands. So this is regarding what? SQL architecture. We'll see the next topic, SQL command. So till now we got to know that what is SQL, what is the need of having this SQL, and how this architecture will going to work out. So now we'll see how to give a query, how to give a question to the database management system. For that purpose we are having this SQL command. So that the standard SQL commands is used in order to interact with the relational databases. Mainly we are going to write a query. So that queries are nothing but commands. We are commanding, or we are interpreting the database management system. So for that purpose we are going to use this SQL commands that will help us in order to create, select, insert, update, delete, and drop. So these are some of the commands which can be classified into groups which is based on their names. So in that group we are going to have three kinds. One is data definition language, and also we have a data manipulation language, and also we have a transaction control language. So based on the work that is going to process, based on that we are going to have three types. One is data definition language, data manipulation language, and transaction control language. We'll see about this data definition language. So all the commands used to create, modify, or delete physical structure of an object called table, we are going to use this data definition language. So how we are going to remember that? You remember it like a CAD. Okay, so CAD is nothing but C in the sense create, and A represents alter, and D represent drop. So in order to create any table, or in order to create any relation, we are going to use this C, that is create, and we are going to use this alter. For example, if I wanted to do some modification to the existing data of a data structure, at that time we are going to use this alter. And we have this drop. So drop is nothing but completely we are removing the table from the relation, or we are removing that from the schema. That is called drop. There is a difference between delete and drop. So for delete we are just removing all the content which is there in the table. Drop in the sense we are completely removing the table or a view from the database. So that is the difference between delete and drop. But this drops comes under this DDL, or a data definition language. So it includes create, alter, as well as drop. So now we'll see about the second type, that is data manipulation language. In short, it will be termed as DML, or a data manipulation language. So this DML provides the data manipulation technique. What are the manipulation? That means what are the changes we can do? So with the help of this selection, I can select one or two rows, and I can do insertion. That means we can add a new content to the existing table, and also we can delete the existing content from the table or a relation, and we can update. That means I wanted to manipulate a relation or a table, we can also do that with the help of this DML, and also we can do the modification. So update, modification, replacement can be done. We can retrieve, sorting, and display of the data or record can be done with the help of this data manipulation language. So we'll see the next topic, that is regarding data types in SQL. So as we all know that we are dealing with what tables or a relation. Let me write one table for all of you. Consider this as a student table, right? So what student consists of? They will be having student ID, obviously name will be there, and they are going to have the date of birth, right? Fine. It has three attributes that includes student ID, name and date of birth. For example, for student ID, I am going to give as A1. For name, I am going to give the name called Namita. And also for date of birth, 18/12/2006. Okay. So what it includes is all are the value, whatever I am giving for student ID, name and date of birth is all are of same type. I am giving everything in the terms of character, or else I am giving the SID or a student ID in the terms of completely numbers or alphanumeric. So I am taking the date of birth in the terms of date and month format. So what all these indicates, what kind of data we are storing, that indicates the data types in SQL. That means the type of data we are storing in a table or we are storing in a relation for particular column will be termed as what? Data type. Then what are the kinds of data type that we have in a SQL? This is also important question. What are mention the types of or a data types in SQL, and also this SQL data type is an attribute that specifies the type of data of any object. For example, if I consider date of birth, what is its data type? Then what is the data type of this name and student ID? That means we are specifying this name can hold which kind of values, or this date of birth can hold which kind of values. That represents the data type. So in this SQL, each column and each variable and expression will going to have a related data type in the SQL. So what it includes? The types of SQL server data type for the user. So mainly it includes exact numeric data type. So when it comes to the numeric, it will be related to whole number. So it includes int and numeric. Data type is int and numeric. For floating point numeric data types, it includes float and real. And for date and time data types, we are going to have a data type called date time, and we have a date and time. So for example, I wanted to just take time, then time. If I wanted to take only date, date. If I wanted to take both the date and time, then date time. Then we have a character string data types that includes char and varchar. So this is new to everybody. Varchar in the sense variable character. So it will going to hold both alphabets as well as the numerics. So for that purpose, we are going to have this varchar data type. So now we'll see about the next topic, that is related to operators in SQL. So as we all know that when we are performing some of the operations, it can be related to mathematical operators, operations or relational operation, any logical operations. At that time, we will be using this operators in any of the programming language. In the same way, we are also having these operators in the SQL also. So that an operator is a reserved word or a character used primarily in SQL statements in the where class. That means we are going to use this operators. Operators are nothing but what reserved words or a character. So in the SQL, we are going to use that as a reserved word. In short, it will be considered as a keyword or character, mainly in order to work with a where class. For example, where it is not null, where it is greater than. That means in order to perform some of the conditions, in order to have some queries, at that situation, we are going to use this SQL operators. And also, in order to perform the operation, that includes the operation may be related to comparisons or arithmetic operator, logical operations. So in that situation, we are going to use this operators of SQL. And also, an operators are used to specify condition in an SQL statement and mainly to serve as a conjunction to multiple conditions in a statement. So when I am giving a query, not only of a single line, so there could be a possibility of having more than one line of a command. So it will going to build a connection from one query to another query, and in order to do the arithmetic operations or in order to have this comparison, logical operation, in order to do that, we will be having this operators in the SQL. We'll see the first type, that is related to what? Arithmetic operator. It is just a common thing for all the languages. So if I wanted to perform any arithmetic operations like addition, subtraction, multiplication, division, and we have modulus. So main difference between division and modulus. So division will going to return the quotient value and modulus will going to gives you the remainder value. So here you can see that addition. For example, if I am going to write a plus b, at that time it will going to add the content of a with b and a minus b. So the content of b will going to be subtracted from a. And also we have a multiplication. So a multiplies b. So if I take that, it will going to multiply the value on either side of the symbol or an operator. And we have a division, it will gives you the quotient value, and we have a modulus that will specifies the remainder value. This is related to what? Arithmetic operators, mainly in order to perform the arithmetic operations that includes addition, subtraction, multiplication, division as well as the modulus. We'll see the next one, that is comparison operator. This comparison operator can also be considered as a relational operator. Mainly in order to compare one value with another value, we are going to use this relational operator or a comparison operator. What is the first operator that I have here? Equal. That means we are checking whether A is equal to B. If it is true or if it is equal, that means if A is equal to B, then it will going to return true, otherwise it will return false. Then here it is not equal to. A not equal to B. Consider A is equal to 10 and B is equal to 20. So here what we are checking is 10 is not equal to 20. Yes, it is true. Why? Because 10 is not equal to 20. It is true. At the time it will return true. So if it is equal, that means if A is also 10, B is also 10. At the time it equal, then this condition become false. And here also we have an operator called check if the two operands are equal or not. This is also equal or not. For example, A not equal to B. So here also if you consider A is 10, B is 20, here also A is not equal to B. Then it will return true. So if it is equal, then it returns false. And we have a greater than. So if the value of a variable which is at the left side is greater than B, then it will return true, otherwise it will be false. So is 10 is greater than B or 10 is greater than 20, it is false. It returns false in this example. Next we have a lesser than. So it will check whether the variable of a left hand side is lesser than the variable of a right hand side. So if it is so, then it will return true, otherwise it will be false. So here also A lesser than B. So consider A is 10 and B is equal to 20. Is 10 is lesser than 20, it will become true. And also we have greater than or equal to. That means it can be either any one of the condition. It can be greater or it can be equal. If any one of the condition gets satisfied, then it will be true, otherwise it will be false. So here is 10 is greater than or equal to 20, false. So it will return false in this case. And also we have a lesser than or equal to. So if it is either lesser or equal, then it will return true, otherwise it will be false. For example, A lesser than or equal to B. So that means what? 10 lesser than or equal to 20. So here it is not equal, but it is lesser. If any one of the condition gets satisfied, then it will be true. So in this case it will be true. So next what we have? Not lesser than. So it will check if the value of a left operand is not lesser than the value of the right operand. So if it is true, then the condition become true or 1. So consider 10 is not lesser than 20, but here it is false. 10 is lesser than 20. Can't take it as what? Greater than 10 or 20, so that it will be false. And it is just a reverse of this symbol. So 10 is not greater than 20. So what we are checking here, if the value of the left operand is not greater than or not equal to the value on the right operand. So if it is true, then the condition become true. So that means 10 is not greater than 20. So in this case, it will be true. This is regarding what? Relational operator or a comparison operator. We'll see the next type, that is what? Logical operator. So in order to perform the logical operations like logical addition, logical multiplications, so we are going to use this logical operator, logical and, logical or, logical not. We'll see about this operators. So it includes all, and, any, not, or. Already you all are familiar with this or not, but you are now new to this all and any. So what it means, we'll see now. All in the sense what this operator, the all operator is used to compare a value to all the values in another value set. So what it includes, you just imagine you have 10 here, that is the value of one side. So and I have a set of values like 10, 20, 30. Okay, so this 10 will going to be compared with all other values. Then we are going to use this operators called all. That means mainly it is used to compare a value to all the values in another value set. So here I have a set of values called 10, 20, 30. So I will be comparing this 10 with all these three. So if any one of the case is matching with this, then we are going to consider that value that is related to all operator. So already we know about this and. So if both the conditions are true, then only it will going to return true. If any one of the condition is false, then it will be false. So that the AND operator allows the existence of a multiple condition in an SQL statement where class. That means whatever the condition I am using, for example, where marks is greater than 20, where age is greater than 21. At that time, both the condition needs to be satisfied. If both are true, then only resultant will be true. Otherwise, if any one of the condition is false, the output or resultant is also be false. That is related to AND. And here we have any. So what it any will going to do? The any operator is used to compare a value to any applicable value in the list according to the condition. It is like what? We are not giving much conditions, or we are not giving more criteria. So apart from that, we are checking whether any one of the value will going to match with any one value of this particular value set. For that purpose, we are having this any operator or any logical operator. So I am just checking, consider I have 10 here and here also I have 10, 20, 30. So is there any matching between this 10 and 10, 10 and 20, 10 and 30? We are just comparing. So we are just making this logical operation. So that mainly it is used to compare a value to any applicable value in the list according to the condition. So is it is like a switch statement. So we are dealing with multi-way branching. In the same way, this any will going to takes place. And also we know about this not. So not operator reverse the meaning of the logical operator with which is it is used. For example, if the input is true, then the output will be false. If the input is false, then the output will be true. That is related to not. What about this or? If any one of the condition gets satisfied, then the resultant will be true. So that is the OR operator is used to combine multiple condition in an SQL statement where class, for example, where girl name or where student ID is equal to 1 or their marks is equal to 40. So if any one of the condition is true, then they are going to consider, they are going to take that for consideration. So that is what OR. This OR is mainly meant for addition and this AND is mainly meant for multiplication. So if all the conditions are true, then only it will be true. If any one of the condition is true, then it will be true. That is related to logical operator, and you have to remember all these operators are very, very important question for 5 marks. Or else they can ask you to mention of the operators in SQL. This is related to logical operator. So we'll see the next topic that is related to SQL expression. So till now we have learned regarding what is operand, operator, what are the operations that we can perform. So these SQL expressions are somehow like formulas, and they are mainly write in a query language. Then what is this SQL expression is all about? So an expression is a combination of one or more values. It can be a combination of one or more values, operators and SQL function that will going to mainly in order to evaluate a value. For that purpose, we are going to use this SQL expression. Mainly, it can be a combination of operators, operands or any of the values, or it will be treated as a formulas. Mainly, we are going to use this in order to write in a query language, in order to write a query, and it will going to include SQL functions. So this is related to SQL expression. What are the types we have in SQL expression? So it includes SQL Boolean expression. So Boolean in the sense either true or false, right? So here it will fetch the data on the basis of matching single value, whether it is true or false. If it is true, some value will going to be accessed. If it is false, another value. That means based on a matching of a single value, this Boolean expression will going to takes place. And also we have a numeric expression. So mainly if I wanted to perform any of the mathematical related operations or in any of the query, then we are going to have this numeric expression mainly. So if I wanted to perform any of the mathematical operation in any of the query, then we have to use this numeric expressions. And also we have a date expression. So this date expression return the current system date and time values. So if I am using this date expression in my query, at that time whatever the current timings and its date is there in the system, that will going to be displayed as a resultant. This is related to SQL expression. So now we got to know regarding what is SQL, how SQL architecture will going to work, and we got to know regarding the SQL commands. So that includes DML, DDL and TCL, and also we have learnt regarding the data types in SQL, and also we have learnt regarding the operators in SQL. Then we are done with this SQL expression. So now we'll see some of the constraints or rules with respect to this SQL command. So what is the first one that we have? Mainly it is related to primary key constraint. So already we know what is primary key. So in order to uniquely identify a row or a tuple in a table, we are going to use this primary key. So mainly this primary key, in order to call any of the column or an attribute as a primary key, or if I wanted to make any attribute or a column as a primary key, it has to satisfy two things. One is what? The values must be unique and it should not be null. So it should not be null. That means we cannot leave the blank space for that value. So for that column we can't leave the blank value, or we can't use null values, and it should be unique. That means it must be unique in nature. For example, if I have a 5 rows in my table, all the values of that column should be differ from one and other. That is the two condition has to be satisfied for this primary key constraint. So you can see here, as of now you just understand we are just creating a table. So for example, let me consider this is an employee table. Okay, consider this table name as employee, and here you can see that create table employee. So what I am doing, I am just creating a table of a name called employee. Table name is employee. Then what are the columns it includes? So it includes encode. Let me consider the first column as encode. Then its data type is integer. So I am mentioning the data type of this encode. For example, if I wanted to give a value for this encode, that must be in integer. Next, not null primary key. So I am making this encode as a primary key constraint. I am making this encode as a primary key. That means whatever the value that I am going to give for this encode column should be unique in nature and it should not be null. I can't leave blank. That is the main constraint you have to understand. And also we have a E name, that is employee name, character 20, and it is also should not be null. So we have to specify a name of an employee. Then we are going to give the gender. Then also it includes grade. Then we have gross salary. So these are the columns of this employee table. And we are making this encode as a primary key. For example, if I am taking 1 and 3, so you just look at this table. So I left blank for the value of second row in the table called employee, but we are making this encode as a primary key. So that means what? I can't leave it as a null, or I can't leave it as blank, and I can't also take this 1 or 3, because the values whatever I am giving should be unique in nature. So it should not be left as a null. So then only we can consider that as a primary key constraint. We'll see the next thing, that is foreign key constraint. For example, you just imagine when you are in India, at that time you are the citizen of this country, but when you visit any other country, then you will be the foreigner of that country. So in the same way, if I have a primary key in my table, then that will be the primary key. So if that primary key value which is present in any of other table, that will become the foreign key. So now you consider two tables here. One is table 1 and another one is table 2. Consider this as a student table. This is the marks table. So in this I am going to have a student ID. Along with that I will be having name. So here I am going to take a marks ID, and also I will be taking a student ID. So as we all know that this student ID is the primary key of a table 1. But when this primary key of a table 1 is present in any other table as a key, then we are going to call that as a foreign key. So for this table 2, MID or a marks ID will be the primary key, and the student ID will going to be work as a foreign key. In the same way, here you can see that create table items. We are creating a table called items, and in that we have a item name. Okay, so we are making that as a primary key. You should not leave it as a null. So we have to give some values, and it must be unique in nature. So this is what end of this item table. And I have one more table called orders. So in this order, I have a order number. Order name is the primary key of a table called order, and also I have a item number. So this item number is a primary key in the table called items, but now it will going to act as a foreign key in the table called order. This is related to foreign key constraint, and it is also, it will going to reference as the items in the item number. This belongs to this item table. So this item number is a primary key for items, but when it comes to the orders table, then it will going to act as a foreign key in the order table. For orders table, order number is the primary key. Next constraint is what? Check. So that means we are checking some condition. So if that is true, or if it going to satisfy, then only it will going to proceed in order to go further. Create table employee. Here also I am creating a table called employee, and here encode is the primary key, and it is of a data type integer. It can't be null, and we are making that as a primary key. And ename we have a gender, we have a grade. So we are giving a value default for grade. So whatever the number of employees we have, everybody will going to have a same grade called E1. And also we have a gross salary here. Then we are using this constraint called check. So what it indicates, whether I am giving the value which will going to satisfy the conditions or not. For example, if you are applying for anything, at the time in the application form, there will be a phone number. So they are going to mark that as a red star. That indicates what? That is mandatory field. So if you are giving only 8 digits, or if you are taking more than 10 digits, then that will going to give the notification like invalid phone number. That means what? They are checking the number of phone number should not be greater than 10 and should not be lesser than 10. So we are using that check constraint in order to check some condition, in order to make that condition get satisfied, in order to get the efficient and effective resultant. So here we are checking gross salary is greater than 2000. If it is only true, at that time it will going to proceed in order to give the value for gross salary, or else we are just checking is gross salary value is greater than 2000 or not. This is related to check constraint. Next we have a not null constraint. So as we all know that if I don't want it to give a null value, so it should not be left as a blank space, then we have to use this not null. So wherever I am going to use a mandatory field in the application, then we can't leave that blank. Everything needs to be filled. So in the same way, we are going to have this not null constraint. So for that purpose, if we do not want to allow null value, I don't want to give a null value in any of the rows or in any of the table in my database, at that time we have to use this not null constraint. So you can see here, create table customer, that includes SID. So it can include SID column, and it should not be not null. So that means what? can't leave this SID column as a blank. So it should not be null. So we have to fill some value. That is the not null constraint. And also we have a one more field called field name, which is of a varchar. Then we will be closing that customer table. This is related to not null. So when you don't want to be the value as a null value, that means that value needs to be filled, then that will be considered as what? Not null constraint. Then we have a unique key constraint. So unique in the sense what? You just imagine I have a table and that table will going to have some of the fields. Consider employee ID, employee name, and their salary, and their age or date of birth, and their phone number. So if I am going to make this employee ID as a unique key constraint, at that time whatever the values that I will be having with this employee ID should be unique to one another. For example, I can't take it as 1, 2, 1, 3. So because this 1 and 1s are not unique, those are identical. So I can't take the values twice. That means when you wanted to avoid the redundancy, when you wanted to avoid the duplicacy, then we have to use this unique key constraint. So you can see here we are creating a table called employee, which has a encode as a field here, and it should not be null and it must be unique key. So whatever the values that I am giving for this employee ID or for this encode or employee code, at that time it must be unique in nature. That is represents this to unique key constraint. We'll see the next constraint that is related to default constraint. What is this default constraint? I don't want it to give any value other than my fixed value. That is what default. We are making simply it as a default. Nobody can change that value. Like for example, if we have 50 students in one section, at that time instead of registering or instead of giving the value of all the 50 students as E1 or section E like that, I'm just making that 50 student, all the 50 students belongs to particular section called E. That means I'm making that section as a default E. So that is what we are trying to do in the default constraint. If I don't want it to give the value for any of the field or just I wanted to make that value as a default value, then we have to use this default constraint. For example, if we have all the 50 student as a girl, then no need to ask the gender. That means at that time what we are going to do, we are going to make that gender constraint, or we are going to make that gender column as a default value called female. So that is what we are trying to do with this default constraint. We are going to have a creating of a table called employee, and it includes encode, and we are making that as a primary key, and we have a E name, gender. So we are taking the not null constraint. I can't leave the blank for this employee name as well as their gender. And also we are having this grade. So grade in the sense they are belongs to which category. So their grade, they are defaultly, they are giving that grade as a E1. For example, that employee table has 50 employees. You consider that employee table has 50 employees records or a tuples. So at that time, wherever the grade column we have for all the 50 employee, I am just simply initializing that as a default value called E1. Let me write here, consider this as a employee table, and that includes employee ID and employee name will be there and their gender will be there, and we have the grade, right? And at last we have a gross salary. So what is the employee ID? It must be primary key, it must be unique, and I can't leave a blank space for this name as well as the gender. So consider this as Suresh, gender will be male, and Suma female, and Anu female. Okay. So here when we have a grade, instead of taking a value for the Suresh or Suma or for Anu, I'm simply defaultly we are giving that grade as E1. That is what we are doing with the help of this default constraint. No need to give the value for all the 3 tuples or a record. So I'm just initializing this grade column as a default value with a default value. That is what the use of having this default constraint. So then we have to fill this gross value. I hope you all understood. It's all about today's session. Let me meet you in the next session with a continuation of this chapter itself. Until that, keep learning, keep on growing. Thank you.